Hi everyone, I am Rajitha, working as an Assistant Professor of Artificial Intelligence and Data Science Department in SNS College of Technology. Today, we're going to see about fundamentals of the analysis of algorithm efficiency. So in slide 1, Introduction to Algorithm Efficiency. Uh, Algorithm efficiency refers to how well an algorithm uses computational resource such as time and memory to solve a problem. In real-world computing, the same problem can often be solved using different algorithms. Some may be faster, while others may consume less memory. Understanding algorithm efficiency help us choose the best possible solution. Efficiency analysis does not focus on how fast a program runs on a specific computer. Instead, it focuses on how performance changes as the input size increase. This makes the analysis independent of hardware programming language or compiler. In today's world of big data and large-scale applications, efficient algorithms are essential for handling millions of input smoothly. And why analysis algorithm efficiency? There are three main reasons to analyze algorithm efficiency. Compare solution, predict performance, optimize resources. So when compare solution is when multiple algorithms solve the same problem. Efficiency analysis help identify which one perform better for large input and predict performance. By understanding growth patterns, we can predict how an algorithm will behave when input size increase from hundreds to millions. And optimize resource efficient algorithm reduce execution time, memory and usage, energy consumption and infrastructure cost. This is critical in embedded system, mobile device and cloud platform. And time complexity. Time complexity measures how the execution time of an algorithm grows with respect to input size n. Instead of measuring actual time in seconds, we count the number of basic operations such as comparison or assignment. Why do we ignore clock time? Different machines have different speed. Same program may run faster or slower on different system. Time complexity help us understand scalability. An algorithm that works fast for small input may become unusable for large input size. Space complexity. Space complexity refers to the amount of memory an algorithm requires during execution. It includes input space, memory needed to store input data, auxiliary space, extra memory used for variables, arrays, regression, stack, etc. An efficient algorithm balance both time and space in real-world system and mobile applications. Memory efficient algorithm are often preferred. And asymptotic analysis. Asymptotic analysis studies algorithm performance when input size become very large. That n implies it's infinitive. Uh, Key ideas. Focus only on growth rate, ignore constant and lower order terms, eliminate hardware dependency. This allows fair comparison between algorithms. For example, an algorithm with big O of n growth will always outperform big O of n square for large inputs regardless of constant factors. Asymptotic notation. So big O notation represents the worst case upper bound of an algorithm. It guarantees that execution time will not exceed a certain limit. Big omega represents the best case lower bound. It tells the minimum time required. Big theta represents the tight bound. It describes exact growth behavior when best and worst cases are the same order. These notation help standardize algorithm analysis across platform. Three cases of analysis: best case, average case, and worst case. Best case is minimum time taken under ideal input conditions and expected time taken over all possible inputs, and the worst case is maximum time taken under unfavorable condition. And impact of efficiency: better algorithm design, scalable software system, reduced execution and maintenance cost. And this is the mind map for uh, analysis of algorithm in efficiency. So algorithm efficiency evaluate time and space usage. Time and space complexity help measures performance. Asymptotic analysis focus on large input. Big O, omega and theta provide standardized comparison. Efficiency analysis is essential for real world software development. Thank you.